Ja, weet ik. Weet ik. All right. Welcome, everyone. Please, for those who haven't done it yet, take a seat. Welcome to again, the fifth lecture of the Week of Inspiration. We have a special lecture today because it's organized by the Center for Engineering Education. So I would like to only tell you one practical thing. You can leave at at 13:40 if you have a lecture after this lecture, and you can find the lunches at both entrances at the sides. Otherwise, Eric Mazur will be answering your questions, so feel free to stay longer. I would like to give the word to Jan van der Veen from the Center for Engineering Education.
Thank you very much, Eric, for organizing this very inspiring Week of Inspiration. And welcome to our staff and students that are here present for this lecture of Eric Mazur. Let me briefly introduce him before I hand over. Eric Mazur started his career in Leiden University, and after his PhD he went to Harvard University. There he is a university professor of physics and of applied physics. He works in the area of optics, and he has many honorary doctorates and honorary professorships in different universities around the world. He is not only active in physics, but he is also very active in the area of education, and that is what his lecture will be about. He covers topics like peer instructions. I've seen the booklet on many bookshelves. Active teaching, project-based education, which connects well with our Twente education model, I think. So there are many issues, and in particular today he will address the issue of assessment. So how can we learn to use assessment in a way that it not only serves the purpose of checking the learning goals, but also that it will be favoring the learning. I hope you will have an inspired lecture by Eric Mazur, and I hand over to you. Eric, the floor is yours.
Well, thank you. It's a great pleasure to be back. I know we have a few hundred people here. So I thought, I better find out what she's doing. She told me that her company was making flashcards, you know, these cards that have questions on one side and answers on the other. I'm sure among the students here, some of you may have used those cards. She was basically designing a program for smartphones to use flashcards. Now, those of you who know about my career and my interest in education know that I do not place much value on memorization. So I almost rolled my eyes. I managed to remain polite though. It so happens that earlier that week, I had attended a talk at Harvard by a very well-known psychologist from Washington University who studies memory, and in particular he studies retention from studying with flashcards. And in a paper, which he published in about 2010, 5 years ago, and which got a lot of international press coverage, and appeared in Science, he showed that if you study with flashcards, you remember quite well for 1, 2, maybe 3 days. But if you take students, you have them study with flashcards, and then you wait 1 week, and you study how much they retain, you find that they remember only 35%. If you wait another week, you can barely measure what the retention is. I thought she should know that. So I took my iPad out of my briefcase and I looked up the article and I put it on the screen and I handed her my iPad. It had this graph that shows 85% retention after 2 days, 35 after 1 week. I handed her my iPad. She looked at it for no more than 10 seconds and then handed me back my iPad. And she looked me right in the eyes and she said, "But we only guarantee that they will pass the test." I never thought about it that way. I'd spent my entire career trying to improve classroom instructions, but never really thought about the assessment. And it brought back all kinds of memories. My daughter, my oldest daughter, was an undergraduate at Harvard. So on the weekend, she would often come back home. And on Monday morning, we'd drive back to campus together. We would often talk about learning and studying and how to make the most of a course, as you might imagine, with somebody who is, like me, interested in learning and studying. I remember one Monday morning driving back. I was in the driver's seat. She was sitting to my right in the passenger seat. And I look over my shoulder, and there she is with flashcards. "Natalie, what are you doing with flashcards?" "I have to learn all of these amino acids." I said, "Amino acids? I have an app for that." Seriously, some of my work is in biophotonics, and occasionally I need to know the amino acids, but I'm not a biologist, so, they don't stick. But whenever I need to look them up, I just look them up on the app. She looks at me and she says, "Dad, I'm not allowed to use the iPhone during an exam." And it made me realize that even students who have the best of intentions of learning are forced to use strategies that really don't promote lasting learning. Now, I'd spent most of my time, this is a very old picture of me teaching at Harvard. The picture was taken BC, before computers. You see, I'm using an overhead projector there. I spent most of my career bashing the lecture as an outmoded approach to disseminating information. This little anecdote made me realize that not only our approaches to teaching outmoded and focusing on information transfer, the assessment too is focused on often the regurgitation of memorized information or memorized rote procedures. And consequently, instead of developing 21st century skills, our assessment is focused on ranking and classifying students. And I will argue that our ability to actually effectively rank and classify people is very limited. So here's what I'd like to do. I would like to start by reflecting on the purpose of assessment, and I'm really thrilled that we have in this room right now a mixture of instructors and students, because I think you might have very different perspectives on the purpose of assessment. Why are we doing an assessment? What is the goal of assessment? Then I'd like to tell you about some problems I have identified with our current practices for assessment. And because I don't want to end on a negative note, I will end by suggesting some potential improvements in our assessment approaches. So let's start with part one. I want you to get together with some people around you, 3, 4, whatever, appoint one note taker, and write down as many purposes of assessment as you can think of. So go ahead, talk to each other, and I'm going to give you a few minutes. Op papier.
Learning goals, doe maar.
Hoeveel hebben jullie op papier?
We zijn al bij
3, 4, 4.
De studenten zijn al bij 7.
Echt waar? Zo.
7?
Just out of curiosity, and I'm sorry to scare you like this, how many of you have more than 5 reasons on paper? Students here in the front are doing really well. Okay, good. Some of you need to work harder, but we don't have that much time. So let's report back, because I hope that collectively you'll be able to come up with quite a long list. So I'm going to ask you to feed something back to me. Each person is only allowed to, you don't rattle off your whole list. Just take one thing off your list, and then somebody else can say something else from their list. So go ahead. Is there anybody who wants to start? So, and I'll repeat it so that people can hear it, and people who are at the live stream can hear it too. So, to see whether or not the learning goals have been met. Next one.
Check skills.
2, check skills, which I would put under the same umbrella probably as check skills. Yes?
Extrinsic motivation to work.
Extrinsic motivation to work. If I don't assess you, you're not going to do your work. Okay, in the back. Reward and punishment, which falls into the same category, I think, as extrinsic motivation. Yes? To provide a platform for students to showcase their ability. Yes? To rank students. He's better than she is better than he is, and so on. Yes? To provide feedback. Very good. To provide feedback to whom? To the students. Very good. Yes. That's great. To provide feedback to the teacher about how the students are doing, or what the effectiveness is of the teaching. Yes. To check if the students qualify for the labor market. Okay, 1 or 2 more. Yes. to enhance the learning, in order to provide a learning opportunity. Are there some students in the classroom? Yes, I know there are students, you know. How many of you see your assessment as a learning opportunity? Can I see a show of hands? Oh, very good, very good. You should be proud to have that type of culture here on campus. Very good, because on most campuses it doesn't happen. Two more, one there. To get some creative, to sort of unleash the creativity, and all the way in the back there. It's a legal, we just have to do it because other people have done it. Here's what I had written down, and I think you've touched on most of this: to rate and rank the students, to rate the professor in the course. We forgot to say that, but in a sense, it's a rating of the instruction too. To motivate the students to keep up with the work, to provide feedback on learning to the students, to provide feedback to the instructor, to provide some instructional accountability. We heard somebody say to see if students are ready for the labor market. And also, I don't think we heard that, I'm not sure we did, to improve teaching and learning. You know what? You all forgot one really important reason. I'm going to show you a picture just to jog your memory. Here we go. So that we can travel to conferences and keep the students busy back home. I'm just kidding. But I know that some cases I have actually done that and assigned an exam. Think again about that list. How can you do so many different things with one activity? And some of the verbs on that list were already in conflict with one another. Reward and punishment. How conducive is that to learning? So we see right off the bat here that because we try to do so many different things with this activity, already getting into trouble, but it goes deeper than that. I already mentioned the fact that I thought that much examination is simply the regurgitation of information, is not an authentic assessment of knowledge. But I would say that even exams that claim to test authentic problem solving do not do so. It's inauthentic problem solving. Let me explain what I mean. What is a real problem? A real problem is something where you know what the desired outcome is, you know it, but the question is, how are you going to get there? What is the solution to achieve that unknown outcome? I mean, in any engineering design problem, you know sort of the end product, but the question is, how are you going to realize that end product? But even for any daily life problem, you have an interview in New York. You take the train to Schiphol Airport, and you arrive there, and the last flight to New York has been canceled. You got a problem. You know what the desired outcome is. The desired outcome is being in New York for that interview. The question is, how do you get there in time for it? So think about any type of problem you face in your life. It fits that pattern, a known desired outcome, an unknown path to that outcome. Now compare and contrast that. I think in the humanities people are doing a little bit better, but compare and contrast that with a typical examination problem in the sciences. Take my own discipline, physics. People are giving a problem where they're asked to apply a known procedure to find an unknown answer, and you evaluate on the answer. A car is going along a road, blah, 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 and so forth, and then eventually it hits a tree. What is the velocity of the car just before it hits the tree? Student thinks, I know about this equation to calculate velocity, that equation, that equation. This equation I can't use because I don't have all the variables. Maybe this one. This one I can't use, I must be using that one, and you plug the numbers in, you turn the crank, out comes 4.2 meters per second. Correct or wrong, depending on what the desired answer is. You're evaluated on the answer, not on the process of finding the answer. Let me put this in light of Bloom's taxonomy. Benjamin Bloom was an educational psychologist in the 50s who basically made a taxonomy of thinking skills, going from lower order thinking skills to higher order thinking skills. At the bottom is remembering facts. Then comes understand how facts are interrelated. Then comes applying, taking what you've learned in one context and applying that to another context. Then comes analysis, determining what kind of knowledge you need in order to solve a certain problem. Evaluating, verifying that the solution you have actually satisfies the problem you started out with. And all the way at the top is that magical, elusive goal that we all try to achieve. Innovation and creativity, creating new knowledge, creating something that is new. I would argue that in most educational settings, we do not even get to level 3, applying. Taking what you've learned and applied it to a different domain. Not that long ago, I was actually at a university in Connecticut. I won't name any names, but it's a really good institution. And I gave a talk about teaching. And after my talk, one of the professors came to me and said, I had something really strange happen in my course this year. He was teaching physics to engineering students, and he wanted to make his physics relevant to his students. So he put physics in a real-world context. The context he used was baseball. There's a lot of physics in baseball, right? Trajectories of balls, collisions between balls and bats, runners running. So in class, he used examples from baseball. On the homework, he gave the students baseball problems. On the midterm examinations, baseball problems. At the end of the semester, he realized he had run out of baseball problems. So he was writing the final exam. He decided to put some football problems on the exam. Professor complained to students, we've never done any football problems before. You're laughing about it. I don't think it's funny at all. Because you have to admit, if you can't take what you've learned and apply it in a new context, you have not really learned. We want our students to solve the problems that we cannot yet solve. We want the next generation to stand on our shoulders. And our students are very likely not to encounter the type of problems that have already been solved. So we need to equip them with that ability. In fact, whenever a student comes to me and says, Professor, I've never done a problem like this before, I tell the student, look, if you had done a problem like this before, it would by definition no longer be a problem. Let me actually put this a little bit more concretely. I'm going to take something which I think is an interesting problem, which actually tests all the way at the top of Bloom's taxonomy, and then slowly deconstruct it and turn it into a standard textbook problem. I don't know how many of you know about Enrico Fermi, Nobel Prize-winning physicist, participated in the Manhattan Project and became a professor at the University of Chicago. And he became known for starting his classes by asking estimation problems. Now they're called Fermi problems. He would basically walk into the classroom, physics classroom, and say, how many piano tuners are there in Chicago? What does that have to do with physics? Well, you could just guess 200. But a guess doesn't give you much confidence in your guess. The other thing is just to reason it through. Let's see, Chicago, there are 10 million people. So that means there's about 2 million families in Chicago. Let's say that 1 in 10 families has a piano. That's 200,000 pianos. Let's say that on average, people tune their piano. They should really tune them several times a year, but let's say they tune them once every 2 years. So that means that you need about 100,000 piano tunings in a year. How many pianos can a piano tuner tune? Well, you get the gist, right? You can go on. And at the end, you're very unlikely to have overestimated or underestimated everything. You'll overestimate sometimes, underestimate other times, and no matter which way it goes where, you end up actually, by reasoning it through like that, so number 25. And if you actually look in the telephone book in Chicago, you will see that there are 25 piano tuners in Chicago. And you have a lot more confidence in that number than you have in a wild guess. And that's exactly what he wanted to accomplish with his students. Now, I'm not Enrico Fermi, but I'm a physicist too, and sometimes questions like that just come up in my mind. One Saturday morning, a while back, I was painting my dining room, and I ran out of paint, so I had to go and buy paint. So I hopped into my car, drove to Harvard Square, and for those of you who know Harvard Square, there's a hotel right in the center called the Harvard Square Hotel, I think it's now. It keeps changing name. It was Harvard Motor Lodge before. But anyway, this hotel sits on stilts, elevated. And at street level, underneath the actual hotel, are 2 parts of a parking space with 20 spots each. So there's a street, 1 space, another street, and another space. And each of these 2 spaces about 20 spaces, 20 cars that can park. And normally what I do is I go in and there's no spot, so I go out the other street and go back in the other half, and I go in and I go around, and then, you're on the right side, and then you see somebody who is coming to the car, walking towards a car with keys in their hand. You say, yes, I'm going to get a spot. But then you're on the right, and the person goes to the left, so you quickly go out in the street, back in, there's another car that gets a spot right in front of you. So that Saturday morning, for reasons that I don't know exactly, I decided, you know what, I'm going to give up on all of the spots on the left. I'm just going to stay on the right, so that if somebody comes there, I can grab that spot, and I turn the engine off. And as I turned the engine off, the first question that came to my mind is, how long is this going to take? And I thought about it for a moment, and after about 30 seconds, I came up with an answer, 3 minutes. So I looked at my watch. You know what? 3 minutes later, somebody came and freed up a spot, and I felt so good. Now, imagine we turn that into an examination problem. Here it is. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before someone frees up a space? I guarantee you, if you put this on one of your exams, your students are going to go to the dean to try to get you fired. What are some of the skills you need to answer this question? You need to make assumptions. You need to develop a model. You need to then apply that model. In terms of Bloom's taxonomy, we're all the way at the top. Look at those skills on the left. What of those skills that are listed there do the students hate the most? I want the instructors to answer this, because you students, you all know it. So which is the skill that is the most frightening of all of those? I hear several people whisper it very shyly. Assumptions, yes. What if you make the wrong assumption? Well, we're never trained to make assumptions. It's a very important skill. What distinguishes one businessman from another, a successful one from a not so successful one, is the ability to make good assumptions. Same for anybody, an engineer, a physicist, a scientist, whatever. It's not the ability to plug in numbers and solve differential equations or whatever. No. It's the ability to make valid assumptions. And of course, you might not immediately make valid assumptions, but the great thing is you can always revisit your assumptions. However, assessment doesn't allow revisiting anything. You do it, if it's wrong, it's wrong. So I don't know about you, but I know that when I set an exam, if I don't specify every little detail, a hand will go up and say, Professor, are we supposed to assume to ignore friction here? Even though it's perfectly clear from the context that friction plays no role. They want you as an instructor to take the responsibility for the assumption. So let's put the assumption in. We're going to now slowly take away these frightening parts of this problem. We add just one sentence. On average, people shop for 2 hours. 2 minutes, obviously too short. 2 days, too long. 2 hours is sort of right in the middle. In terms of Bloom's taxonomy, we're still almost at the top. Only the top of the pyramid has become white, but it still requires quite a bit of creativity. Students would still revolt. What does this have to do with chemistry or physics or business or engineering? We've never done anything that has to do with developing a model for parking lots. So, okay, so let's put the model in. We add one more thing here. Assuming people leave at regularly spaced intervals. Now, the problem implicitly gives all of the information. In terms of Bloom's taxonomy, we've dropped all the way to maybe the applying level. We're far down Bloom's taxonomy. And still, students would revolt. Professor, we've never done any parking lot problems before. So let's now turn it into a standard textbook problem. Here we go. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area where people are known to shop on average for 2 hours. You decide to circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before someone frees up a space? And you go, isn't this the same problem we started with? Yes, but somewhere in the textbook or in our classes, the students have encountered this equation, which is colloquially known as the parking lot equation. The amount of time you wait is the amount of time that people shop on average divided by the number of spaces. And the only thing they need to do is plug the numbers into their calculator. In terms of Bloom's taxonomy, where are we now? All the way at the bottom at remembering that equation. Maybe I exaggerate a little bit, but I urge you to take a cold, hard look at examinations, in particular in technical fields like science and engineering and mathematics, and you'll find that a lot of problems are closer to the end form of this problem than the beginning. And I think this is particularly important in the 21st century because computers can do this. Computers can solve problems by rote. We all carry our devices that can solve those types of problems in our purses or in our pockets. And therefore, I predict that just as assembly line jobs have been replaced by robots, so will any job that requires the memorization of information or the application of rote procedures be replaced by a computer. In fact, it's already happening. And therefore, we really must focus on real problem solving, on the type of jobs that are not going to be replaced by computers. But as I said before, there's something frightening about it because authentic problem solving is erratic. In fact, I would argue that the road to creativity, the road to innovation, is littered with failure. Thomas Edison, who invented the light bulb, oh, I see you have LED lighting here, that's pretty good. But anyway, Thomas Edison invented the light bulb, not by just building it and doing it. No, I think he had something like 300 failed prototypes. Failure, 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 failure. I mean, most people would have told him, you're crazy, you're insane. But he persisted. Failure is something frightening for most people because it's not seen as an opportunity to learn. And in light of the assessment, it's even more frightening, right? If you take an authentic problem, you may try an approach and may not work. You need to backtrack, try again. Second approach doesn't work either, try again. Third approach, if you're lucky, it works after 3 times. If you're Thomas Edison, it might take 300 times. Unfortunately, our grading practices are incompatible with that. You fail means you make a mistake, you lose points. And therefore, our students become risk averse. It's frightening to make a mistake. I'm going to switch gear here for a moment. Look at this picture. You saw right away what this picture represents. And if this picture evokes any pleasant memories, then after my talk, I would like to talk to you. What are some of the feelings that come to mind when you see this picture? Just blurt it out. I'll repeat it. Isolation, boredom, stress, concentration, anxiety. These are all words that are so conducive to learning. It's just fantastic. One person, the first person to say something here, very perceptive. You know, usually when I show this to an audience of instructors, I do not hear that word. I have to fish for it. Isolation. Look at that picture. The people are isolated from each other, cut off from each other and from any source of information. Isn't this the way we all work on a daily basis? That was a joke, by the way. It was cynical. You know, look at their tables. They have pencils. They don't have a calculator. They have nothing. You know what I recently read in the New York Times? That for the SAT, the Scholastic Aptitude Test in the United States, you're now no longer even allowed to bring your watch, because it could be a smart. Soon they'll have to take these examinations naked. Ask yourselves, since taking your last exam, this is a question aimed at the instructors here, not the students. Since taking your last exam, which may be not that long ago or maybe a long time ago, have you ever encountered a situation where you have been similarly cut off from any source of information or any other human being? I see lots of people shake no. No, we don't work like that. Then why? Oh, why do we test our students that way? How can we imagine that by testing students under these circumstances, we're going to measure anything that's relevant in our students' later careers? When I write a paper on nanophotonics, which is my area, in my office, there's not somebody standing next to me saying, you're not allowed to look up that paper by your colleague at Yale. You should have known this by heart. I can look up whatever I want, whenever I want. I can consult whoever I want. It's not called cheating. It's part of advancing knowledge and doing work. So, isn't that kind of peculiar? Now, traditionally, assessment has been a high-stakes affair. This is why we heard the word stress, anxiety, and so on. Culminating in the final exam, students are told to study for the exam. But studying for exams promotes cramming, and as I've argued before, cramming only stores the information in short-term memory, and consequently there's no retention, no transfer. You know, something interesting happened on my campus a year and a half ago. December 2013. You may have heard about it because it was on the international news. I was in Hong Kong. It was 7 p.m. in Hong Kong, 7 a.m., first day of the examinations at Harvard. I just came back to my hotel room from a day of lecturing at Hong Kong Polytechnic, and my phone buzzed, and I looked on it. It was emergency alert system from my campus. If you're on campus, do not get out of your building. If you're not on campus, stay home. I thought, what in the world is happening? So turn on the TV, CNN. There's my campus, and the Science Center, which is right next to the building in which my office is. Yellow tape, police cars, trucks. There was a bomb scare. Actually, it turned out later there was a student who didn't want to take the exam and had called in 4 bombs in 4 different buildings. An hour later, 8 o'clock, still 1 hour to go before the exam started, a next alert message, everything is clear. You can go out again and walk around on campus. And 15 minutes later, I got an email from the dean addressed to the entire academic community, student and faculty. He said, in light of the activities that happened, even though everything is clear now, I have reluctantly decided to postpone the examinations that were going to be held in those 4 buildings, Science Center, Seaver Hall, University Hall, whatever it was, and postpone them for 3 days. And I realize that this causes a problem for the students because they have studied for the examinations. Hello? It's a problem. 3 days. Shouldn't we study for life rather than study just to pass the test? Then there's grades. Grades are a measure of relative standing to others. And the other part of assessment is the feedback. We heard that loud and clear earlier on in this talk, which is basically a reflection on what has been learned or what has been taught. Research has shown that if you attach a grade to an assessment, students focus on the grade. Take the grade away, and students focus on the feedback. You don't need to attach a grade. You can just assess and say, this is great. This is not so good. You may want to reconsider this. You put a grade there, and the students are mostly concerned about the grade and getting the highest possible grades in order to meet the minimum requirements to move on. On the other hand, if you give the feedback, it provides an opportunity to learn. And unfortunately, the grades interfere with that feedback. Then there's more. Assessment produces a conflict. You see, now I teach a project-based course. We have no examinations at all anymore. We still have assessment, we just don't have examinations anymore. And I basically, during most of the year, coach my students to be the best they can be. But then at the fair, where they demonstrate their projects, in the beginning, I would become the judge. Now, I'd known how hard, because I'd looked at these students working on their projects so closely, I knew how hard they'd worked. I wanted to give them all A's. I knew how hard they'd worked by taking ownership of their learning. I wanted to give them all A. That's when I realized, this is kind of weird, right? Am I the coach or am I the judge? How can I make this Jekyll and Hyde transition? I'm going to help you, and then all of a sudden, you know, I'm not going to help you, I'm going to be the judge. In fact, I can think of no other human endeavor where we combine the role of coach and judge. It would be unacceptable. You're a figure skater coach, let's say, and now you go to the Olympics, and you say, goodbye, do your best, I'm going to be the judge now. It would not be tolerated. How do we get away with that in education? I'm really honestly starting to think that education is just one big cartel. You know how we get away with this coach-judge conflict? We get away with this coach-judge conflict by hiding behind a thin veil of objectivity. I'm going to judge you in a way that involves no feelings or emotions, that is reproducible and objective. But let's look again at Bloom's taxonomy. Look at those skills there. Which is the one that you can assess truly objectively? There's only one, all the way at the bottom, remembering. In what year did World War II end? 1945, right. 1946, wrong. Or what's the velocity of the car that hit the tree, of what I mentioned before? If the students write down 4.2 meters per second, right. 4.2 without meters per second, wrong, you forgot the units. Minus 4.2, wrong, wrong direction. 4.6, wrong, no feelings, nothing. But you're all the way at the bottom of Bloom's taxonomy. You're not testing the type of thinking skills that students really need. And then there's more, grade inflation. You look all around the world and grades are inching up and up. We don't want to rob the students of their, beurs, as you call it. Oh, interesting. Where does that come from? Yeah, here we go. This is weird. I don't know where that is. Cancel. Okay. There's more. There's grade inflation. And then there's cheating. Why would somebody who is intrinsically motivated to learn, why would a learner cheat? You're robbing yourself of an opportunity to learn. Have you ever seen a 4-year-old cheat while learning how to tie their shoelaces? Or a toddler who is learning how to put the fork in their mouth cheat? No, of course not. So cheating is not a problem with students. Cheating is a problem with the assessment. Okay, well, I said I would not end on a negative note, so let's talk about improvement. The first one is, let's mimic real life. Let's give students access to information. They're going to have access to information later on anyway. In fact, I knew this very early on in my teaching career. And I said, I don't want these pre-medical students I teach to memorize Kirchhoff's laws and all these other equations. So I made a sheet that had all the important equations on there, the first year that I taught physics. Then the next year some students came to me and said, they had seen the sheet, and they said, you know, can't we bring our own sheet of formulas to the exam? So that, okay, one index card, 5 by 7 inches, one side only. Only to discover that students develop a microscopic handwriting where they put the entire book on one index card. So the next year I said, you know what, just bring the book. The following year, some students came to me and they said, in high school, I used this other book for physics, which I like more than the book we're using in this course. Could I bring my high school physics text? I thought, well, if I do it for this students, I have to do it for other students who might have used different books. So I thought about it for a while. I said, you know what, you can bring any book you want to the exam. Some students come in with a stack of exams. The following year, some students came to me and they said, could I bring the solutions to the homework and my notes to the exam? You know what? You can bring anything you want to the exam except another living person. And then, more recently, I started to assess my students on their laptops, which means they have access to Google. Should I cut off the internet? And I thought about it for a moment, and I thought, no, this is actually a good thing. Because what does Google do? Let's look again at Bloom's taxonomy. What Google does is it cuts out that bottom level. Any question to which the answer can be Googled is not an authentic assessment question. This means I have to spend a little bit of time Googling my own questions in order to see whether or not they can be Googled, but it forces me higher up on Bloom's taxonomy. I'm really happy I took the decision because it improved the quality of my assessment, made it much more meaningful. Later on, we're going to have access to information. Who am I to determine what my students need to, quote unquote, know? I think it was Einstein who once said, education is what is left after all that is learned is forgotten. You know, and I'm now in nanophotonics. When I was a student at Leiden, there was no nanophotonics. When I was a graduate student at Leiden, there was no nanophotonics. When I was a postdoc at Harvard, there was no nanophotonics. When I was an assistant professor at Harvard, there was no nanophotonics. I had to teach myself all of that. The information we need changes. A lot of things that I don't need, I forget. Suppose I'd been educated as a physicist without learning the mass of the electron. I'm sure some of you would be horrified. Well, it's not a problem. If I need the mass of the electron, I just take my phone and, you know, Siri, and what is the mass of the electron? And, you know, after a few seconds, she actually, it's pretty good. Let's see, she says. And, you know, and then you can't hear it, but here she's giving it with many more digits that I could possibly remember. And if there's a week in which I need the mass of the electron over and over again, I look it up. If I look it up 10 times, it sticks. It sticks not because somebody told me, Eric, if you don't know the mass of the electron, you can't be a physicist. No, it sticks because I need it and I use it. And this is, in fact, the way we learn. I'm sure this is controversial with some of you. I'm going to switch again. I'm going to show you a little video. This video was taken in Bandung, Indonesia, at the Bandung Institute of Technology. It's from a classroom there. I want you to look at that video and then determine two things. One, what discipline is this? Two, what in the world are these students doing? Here we go. Anybody want to venture a guess as to what the discipline is? Kind of an unfair question because you couldn't hear what they were saying. And even if you could, it's Bahasa Indonesia, and I'm not sure many people speak that here. Any? Some kind of a guess game. No, this is a class of statistics. Have you ever seen students having fun with statistics? Now you have. Now you have. Now, more importantly, what is it that the students are doing there? We heard already guessing game, but what could it be? What part of the educational experience is this? Learning, it says. Okay, what else? Trying to solve a question. They are taking a test. No, yes. I'm not lying to you. Yes, yes. Isn't that a cognitive dissonance? I mean, it's taking a test. Can't be. They're talking to each other and they're having fun. Yes, they're taking a test. This is a technique from team-based learning. If you want to know more about it, go to teambasedlearning.org. One of these educational innovations that started in this management, in the teaching of management, where statistics also plays a role, and has spread now to medical education, but it hasn't spread very much outside of those two areas. The first time that I encountered it was at the University of Delaware. And I was Phi Beta Kappa visiting scholar. So you visit the campus for a few days, you visit different departments, and you attend some classes. And one of the classes I was supposed to attend was a biochemistry class on the second day that I was on campus. So I look at the map of the campus, and at the right hour, I was saying it was 11 o'clock in the morning, I go to the classroom where the biochemistry class is being taught. The class is still empty, there are no students. I came a little bit early, and there were 5 tables with 8 students. No students, 8 chairs around it, and there was a bearded professor who was putting pieces of paper on the table. So I go over to him and introduce myself. So, oh, great that you're visiting today. We're actually having a test today. I said, that's weird. Why would they have me visit a classroom when students are taking a test? So I thought, that's great. I can catch up on my email. So I said, shall I wait outside and, we can talk later? He said, no, 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 no. I want you to take the test. I said, what? What's the test about? He said, hemoglobin. I said, I don't know anything about hemoglobin. But before I could say anything, the students had come in, and I found myself at a table with 7 other students. And, I'd hoped to catch up on my email, but I just sat there. So at some point, we were allowed to turn over the exam. It was a multiple choice exam. My mood wasn't that great, it turned really bad. Anyway, so I looked at the exam. I couldn't answer a single question because I don't know much about hemoglobin. But I saw that the students were looking at these questions, and then they had a little strip of paper where they were recording their answers. 1C, 2B, and so on. After 20 minutes, the instructor came and collected those little strips. The strips were 50% of the credit, the individual accountability for the exam. And then the instructor put on each table 1 card like this, called an if-at scratch card, instant feedback assessment technique. On the vertical, you see 1, 2, 3, 4, 5, 6, 7, 8. Those are the numbers of the questions. And horizontal A, B, C, D. And at the intersection, there's this paint that you can scratch off, like on a lottery card. The first thing that the students at my table did is who wants to be the scratcher? Do you want to be the scratcher? You want to be the scratcher. Okay, so she's going to be the scratcher. And then the scratcher said, 1 was an easy question. I had C. What did you have? C? C? Everybody C? Shall I scratch off C? Yeah, let's do it. Scratch off C. Yes, there's a star, because it's pre-coded so that the right answers have stars. I sat there, I said, okay, so now we're making a game. Why do I need to watch this? I could be doing my email. So my mood did not improve. But then the students came to question 2. Half of the students said A. The other half said B. The Bs didn't want the A to be scratched off. The A's didn't want the B to be scratched off. Don't you remember in class, the professor said that when hemoglobin, blah, 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 all of a sudden they started to talk like biochemists. And at some point they went, oh yes, you're right. I think it's B. Yeah, because also, so they started to argue. It was no longer about the answer, it was about how you get the answer. So, shall we scratch B? B? Yeah, okay, scratch B. No star. How could it be A then? They continued to reason. The crux of the matter is if you get it right the first time, you get 4 points in the team round. You see the first question, they scratched off only once, so they got 4 points. The second one, they had to scratch twice, so they get 2 points. So you can try a second time for half credit. You can try a third time for a quarter credit. So in question 4, they needed 3 times. If you still get it wrong, you know what the answer is. By the end of the hours, the students had learned. They had gotten immediate feedback on what was right and wrong. You had seen many cases of aha moments. Oh, yes, because of the instantaneity of the feedback. And at the end, they walked out relaxed, happy, not stressed, nothing. What's even better, there was no grading. As the instructor, you don't have to do any grading. It's done, crowdsourced in a sense. I came back and I thought, this is fantastic, but I don't like the multiple choice aspect of it. But later, several years later, we developed a program called Learning Analytics, which I referred to before, which allows essentially students to enter non-multiple choice answers. So we do this on the computer. You know, this is a question that would not be good because you can actually Google it, but I want to show off the capabilities of the program. You know, you can say, what is the derivative of fx equals 3x squared minus 6x? And students can just type in the formula, or they can make a sketch or draw a vector. I mean, there's lots of different modalities. It's not multiple choice. So in the 0 round, they answer these questions individually. Then after 20 minutes, I press a button, it puts it in the team round. They see the same questions, but at the top of the screen, it now shows what your other team members have answered. Brent, why do you have 6x? Shouldn't it be 6x minus 6? They go to the board and teach each other. And same thing, if you get it wrong, the program tells you this is wrong, and you get a second chance at half credit. And if you get it wrong again, you get a third chance at a quarter credit, and so on. So if you walk into my classroom during the individual round, it actually looks like a standard exam. It's quiet, except that they have their computers in front of them. They're not allowed to text or email, but other than that, they can use everything they want. Then I press on a button, and it goes into the team round, and it changes the dynamics completely. By the way, before I forget to tell you this, you have to be sure that the individual round, that there's not a single student who comes even close to answering everything correctly. Because in that case, the students will simply, you know, get to know this is the good student, I'm going to just copy his or her answer. The average is on the order of 30 or 40% for the individual rounds. So that even the best student can significantly increase and learn from this experience. So you see, they go to it. You can even see that they're working on different problems. They're taking an exam. They're actually having fun. Second thing, and I'm almost done here because I know that some of you want to go to lunch, is focus on feedback, not on ranking. I mean, can we actually rank? I think it's a total myth. I can make a long list of people who I studied with who got A's throughout everything. But I look back at where they are now, no success. And I can make an equally long list of people who dropped out of college. There's one of them. There's one from my own school, Bill Gates. And there's a long list of people who did not have even any higher education, who were immensely successful. What is our ability really to rank? Here, let me show you some data from my own class. On the vertical, this was a long time ago, and this actually prompted me to change my approach to teaching. On the vertical, you see the final grade on a 0 to 100 scale. On the horizontal is a totally different assessment that I started using in 1990, which is a word-based quiz that looks at people's understanding of the concept of force in words, not using equations. According to the author of the test, anybody who scores below 22 is still an Aristotelian thinker, connecting force and velocity rather than force and acceleration. This is at the end of the semester. 70% of my students is an Aristotelian thinker. If you take a gorilla and you have the gorilla take this test, the gorilla scores about 10 by just randomly answering questions. As you can see, some Harvard students should belong in the primate section of the zoo. But notice the big distribution of grades. There might be some correlation between two measures, but it's not that big. If you ask a physics professor or a graduate student or postdoc to take this test, they'll make one or two mistakes. When I took the test, I got 28 out of 29. I guess I must have misread a question. No, I made a real mistake. So, you know, professors, postdocs, graduate students score at this level. And as you can see, there are some students in my class who indeed do score at that level. But now look at these two students. The one on the left got an A, the highest grade, but was still an Aristotelian thinker. Was able to calculate moments of inertia of complicated three-dimensional objects by carrying out a three-dimensional integral, yes, but did not understand Newton's laws. The person on the right scored at the level of a faculty member on Newton's laws, but got a C. Is this objectivity, or is it an injustice? The next thing is we should really not focus on content, but on skills. This comes from a book by Grant Wiggins and Jay McTighe. In the traditional approach to teaching, the instructor will list the content of the course. In this course, we're going to cover topic A, topic B, topic C, topic D. Then you start teaching it, and then you start assessing. In that case, the course is completely defined by the input, by the content. Wouldn't it make much more sense to apply what is called backward design and start by articulating the desired outcomes? A lot of my colleagues really like that, but they have trouble with it. They'll think about it for a while, and then they say on the syllabus to the students, after taking this course, you will be able to understand topic A, topic B, topic C, topic D. No, you need to articulate it in terms of actions. Solve partial differential equations of this or that kind, or interpret medieval works of art in the context of the history of medieval Europe, and so on. Things for which you can think of acceptable evidence. And then you design the instructional approach to maximize the output. The great thing is that you've actually thought about the assessment while designing your course. So the assessment is not an afterthought. It's an input to design of the learning process. Lastly, we need to resolve this coach-judge conflict. You know what I did? Very simple. I asked my colleagues to come and judge my students. Yes, I designed a rubric and I tell them how to judge, but I'm not making this Jekyll and Hyde transition from good guy to bad guy. Let them be the bad guys. It also actually validates what I do in my classroom in the eyes of my colleagues. If they say, oh, Eric, your students are having fun, they're not learning anything, they can ask my students questions and see how much they know. We should also use peer and self-assessment much more, and I wish I had time to talk about it, but the only thing I shall say is that there are some great online approaches. One of them is called Calibrated Peer Review, CPR, a very unfortunate acronym because Googling it yields lots of other things. But it's a great system of actually, even in very large courses, involve students in their own assessment so that they actually develop these metacognitive skills, this ability to judge their own learning, which is the only way you can progress later in life and regulate your own learning. Oh, I forgot to take it out, so I'm just going to fast forward here because I'm not going to discuss the details because my time is up. I want to end with a call to action. And the call to action is very simple. We must rethink assessment. Because if we don't rethink our approach to assessment, we will continue to educate the followers of yesterday rather than the leaders of tomorrow. And perhaps even more importantly, unless we rethink assessment, the results of our assessment is never going to adequately reflect which students are going to be successful in their later careers and which one will not. Thank you very much. I'm happy
Okay.
to answer questions. I don't know what, but
Yeah, so those of you who have to leave, you can take lunch at the exits now. And we have a microphone here, so especially also for the instructors, if you have questions, then please ask them.